Welcome back, everyone. This article is about currying and partial application. And before we begin, let me warn you in a light way, currying and partial application is where F sharp and functional programming in general begins to get crazy. So be patient, take it easy. It's a concept which is exceptionally alien to those who don't come from functional programming background. So unlike the previous videos, this will be a very code heavy video, though there's an example which is committed on GitHub which tries to explain, but I'll spend more time writing code, and as I write code I'll try and explain what both these ideas are. As a matter of fact, partial application is available because of currying. Currying is what compiler does so that partial application is available. Now, first of all, let's understand what's the meaning of the term application here. So we will essentially play with these two functions to build. I'll build all sorts of examples to clarify what is going on. But we have two functions: add two nums x y, two parameters, which does x plus y, and we have add three nums x y z, which does the addition of three. And if I say let result 1 equals to add two nums 1 and 2, and similarly this equals this 1 2 3, what we get here, I'll also add one more thing to printfn percentage a rest 1 and rest 2. Now the percentage a format specifier is a bit special. It print out any and everything. It's a generic format specifier. We will talk about format specifiers later, but no, you can if you have to print numbers, for instance, you need to use percentage d. If you have to use strings, you have to use percentage s, and so on and so forth. Percentage a prints out everything and takes care of decoration and whatnot. So I am using a for a very specific reason, as we will see. So if I run this particular example, no surprise. So this produces, the first example produces 3, the second example produces 6. No surprise. Now this is application of add two nums function. That is, you call a function and pass all the arguments that the function is supposed to receive. Similarly, this is an example of application. Partial application, as the name indicates itself, is when something is missing. There is a partial application. And partial application is, I'll get rid of this for a moment. And instead of sending or passing these two arguments, I'll just pass this argument. Now, this is impossible in C, C++, C sharp, and whatnot. This is absolutely impossible. You can't call a function without all the parameters supplied. And when you do this in functional programming or in F sharp, this is what is known as partial application, that you are calling a function without sending or passing all the formal parameters. Now earlier when this was executed, we saw the result 3 because 1 plus 2 is 3. Now let's see what happens. And we see something fancy here, fun and whatnot, which is not of meaning to us. And this starts our discussion with what is partial application. Whenever you call a function with less than the total number of formal parameters, In other words, whenever you partially apply a function or whenever you have a partial function, the result value is not the result of the function, but another function is returned. So if I have to write down the function signature of add two nums, it's int sorry, parameter 1 x, parameter 2 y, and x plus y, the result. Now what we are doing here is we are just supplying this, and then we are left with this. And if you look carefully, this in itself could be signature for a function, which is give me an int, I'll give you back an int. So let's try that. Let res2 equals to res1 2, and now let's see what's res2. And now res2 is 3. Res1 was another function created on runtime by just supplying one parameter to this function, which resulted in another function which had this signature, which can be verified by doing this. Res1, after partial application of this function, becomes an int to int function, which I have indicated here also. Now, you may have a lot of questions right now. How is this even possible? That's one side of question. And the other side is what's the practical purpose of it? So I'll address these issues one by one. But once again, what I would like to say at this point is this: for those who don't come from functional background, this is wild. So my advice is to perhaps read all the points I have mentioned on the blog once, twice, slowly get a feel of it, run some code yourself. It's a tricky piece, okay? So quickly revisiting, add two nums is a two parameter function. If I'm just supplying one parameter, in other words, partial application of add two nums, what I end up with is another function. Int becomes, this is now in this entire chain, this bit is supplied. So we are left with this. Also, you can pay attention to the nature of signatures, function signatures in functional world. It's for a reason the functions are denoted or notated in this way. The partial application and the function signatures, the methodology of writing function signatures, there's a close relationship between the two. Now, let's take this as an example. I'll just get rid of this much and write the signature of this function becomes this. Now, add three nums is a three parameter function, 1, 2, 3, which results in another integer. And if you are supplying just the first parameter, you will now be left with this. As opposed to the previous example where the first parameter that you supplied, you were left with this. But since there are more parameters than the previous example, you are now left with this. If you supply, and just to solidify, you can see here, int. If I supply the second parameter, you can get rid of this and it becomes int to int. So back to supplying just the first parameter, and then we will say let res2 equals to res1 2. Now res1 was this, and you supplied one parameter to res1. So res2 should be this, and you can say let res3 equals to res2 with 3, and this is because all three parameters supplied now should be the total of these three numbers, which we can confirm by running. We get 6. Now, as I said in the beginning, partial application is possible because there's something that the compiler does while compilation is happening, and that is known as currying. Currying is a very unfortunate, or rather difficult to, because it has nothing to do with programming. It's based on the name of a mathematician who played a key role in the evolution of functional programming. More on that you can study on the internet, that where the name currying comes from. But currying is a technology which is a technique which the compiler deploys when the compiler encounters multiple parameter functions. Those are rewritten as multiple functions, and each function takes a single parameter. So remember a very key principle here. In F#, functions have there's nothing special about functions in F#. This is a val. Even this is a val. So functions are vals. They are just values. Functions can return functions. Functions can accept functions as parameters. And we will see, we will figure out or explore more and more areas where these issues. This is the central idea in F# or in functional programming, that functions can be returned by functions, or functions can be passed to functions as parameters. This technique or this whole ideology is known as higher order functions and is glorified all over internet in various articles and blogs. But higher order functions in functional programming is a very ordinary thing. It is just the way it is in functional programming. So what compiler does when translating this into a multi-parameter function, that process or that technique is known as currying. So this is what I'm trying to explain here, that at the time of compilation, I've given an example here. So I'll copy these to show you what is going on, and here is currying which I am forcing myself. Instead of using this as a function, I have written another function which is add to nums curried version 1. And if you pay attention, this function has only one parameter, x. And from the function, within the body of the function, I am creating another function which is x from the upper function, the outer function, the main function. And I am internally creating another function which has another parameter, and this function does x plus y, and this function has the return value as the inner function. So when you call this function, this x gets baked into this inner function, and this y, which is parameter of inner, gets here, and this inner becomes the return value of this function. So if I call, instead of calling too many functions, if I simply call res2 equals to this 1 2, I should get the same result, which is 1 plus 2 is 3. But you don't need to write functions like these in order to force currying. There will be cases where you will write functions which return functions, but that's a separate issue altogether. Currying is not something you need to force yourself. So I've given all sorts of examples on the committed code, but here is an issue which worries me at this moment. There's a lot of circular dependence between concepts. So for example, here I have Given another example of a create function which returns a lambda instead of an inner function. So if you don't get it, don't worry. Whenever we discuss lambda as a dedicated topic, you will figure out what lambdas are and how to utilize lambdas. But for the moment, you can assume that lambda is just a fancy way of looking at functions. So here's an outer function with a single parameter. This outer function returns another function. So if you look at the signature of this function, it is x, which is int, which returns another function. And if you remember, that is exactly what happened when we called add two nums with one parameter. Okay, so currying is a multi-parameter function is translated into multiple functions, a series of multiple functions by a compiler, and all those functions in the series, every function has a single parameter, and all the inner functions return a new function. Now you may wonder, it's a fancy technique, what do I do with it? So I have given an example of which I'll copy from here, all right. So here's a good example to understand why to use partial functions, when to use partial functions. So here's a here's an example, and this is somewhat similar to the inversion of control example that we discussed in the last chapter when discussing pure functions. Here's a function which prints date and time. Here is the format for the entire message. Here is the date and time format for the date and the date. So let me also take this function outside to and let me call this function. So string format and date time dot now. Now the message format is date time dot now is 0. I'll use the D format. You can check out the date time formats available on MSDN, and let's see what happens. And we get this date time now is some format of date time. We can change the format and it should have some impact. Yeah, so it's a great function. Okay, it kind of follows all the principles we talked about. It completely operating on it has a side effect because it's printing, but so what we can actually do is make it, but ignore that perhaps for later discussion. We can make this return a string which we can print, but right now the idea is to focus on partial applications rather than the correctness of functions. Ideally this function should not be doing printing. It should be just constructing something which is ready to be printed or ready for whatever. Now let's call this function like this. Let x equals to this. Now remember, this is a 3 parameter function and we have only supplied first parameter. So what does x become? X becomes another function which now takes a string which is the second parameter and a date time which becomes the third parameter and returns a unit. It's returning a unit because printfn returns a unit. So ignore the return type of this function and you can say let y equals to x, the second parameter, and then you can say let z equals to y, current date time, and let's run this. Again the same result, no surprise there. First parameter supplied, second parameter supplied, third parameter supplied. Now, why will you ever do this? You will do this in order to have a specialized version of a function which is general. So if you look carefully, this becomes more specialized than this. And this function makes no assumptions. This function, or rather x, has the string format embedded inside this function. This function is not only the string format but the date format also embedded into this. So the point that I'm trying to make here is that when you partially apply a function, what you are left with is not just a function, it's a function which is now more specialized than its original super general form. What do you do with such functions? A whole lot of things. You can pass those functions to do all sorts of printing in this example. So there may be a function which needs to do printing, but that function only knows date time. That function doesn't know anything else. And then you can supply this, the partially applied function, which is date time and the message format and the date format baked into it, to that function. So to quickly summarize the whole issue, partial application is possible because of currying. You don't need to ever bother about currying per se. Currying is what is happening behind the scenes. Partial application is what you will utilize it as a technique to achieve a lot of good results, which we will see in some time, where you take a function which is highly generalized, you partially apply it, and what you get is a specialized version of it. The more parameters you bake in, if you just specify this, it is slightly specialized. If you supply 2, it becomes more specialized. If you supply everything, it's a full application. One thing that I want to end this conversation is with that, if you understand the whole dependency injection concepts, in C#, ASP.NET Core, or a lot of Node.js frameworks prevalent today, and many more, this technique at a function level is nothing but dependency injection. It's a very simple example. It could have been a very complex case where this function, these were complex parameters, and so on and so forth. What you end up with partial application is you have supplied the dependencies, and what you end up with is a worker function. That worker function is then utilized by rest of the application without realizing what was the partial application done with. So the callers of the remaining function, the output of the partial function, they don't need to know how the partial function was created, what was supplied into those functions, what was supplied at the time of partial application. So dependency injection is a very fancy hi-fi word for a very because people look at dependency injection when looking at the entire application or large modules, but it's a very, very similar idea. So as we move forward, we see more and more things happening in action. You will see a lot of things rely in a very manner of fact way on matter of fact, I meant, on partial applications, and it'll slowly make more sense. With that, I'll conclude this. See you later. Bye bye.